Welcome back to another video homework guide, and in this video my plan is to go over a few problems where I need to sketch the graph for a few polynomial functions. Now for these kind of problems, my plan is to actually skip all the algebra steps, and what we're going to do for these kind of problems is that I'm going to give you the results. So I'm going to tell you what the critical points are, the inflection point, things like that, and we're going to just use those results to actually sketch the graph instead of covering over all the algebra steps. So for this very first problem, I have this polynomial function of degree 3. The very first thing I would do when sketching these kind of graphs is I would actually go ahead and find the Y-intercept. The Y-intercept is generally pretty easy to find for polynomials. The Y-intercept happens when x equals to 0, and when x equals to 0, you're left with just plus 5. So that wasn't too bad. We can find the Y-intercept right away. And then you would have to do the traditional algebra steps where you find the derivative and set that equal to 0. So I'm going to skip that step for this problem. And the critical points happen at x equals to -3 and when x equals to 1. All right, so make sure you are familiar with how to get those numbers. Unfortunately, once again, I'm skipping the steps on how to get those results. I just want to give you the final results and then move on. Okay, so once you have your critical numbers there, I would set up a number line, and those numbers would go on the number line. And you're plugging the numbers you're finding numbers in the regions, and you're plugging them into your first derivative. And if you do that correctly, you'll notice that on the far left-hand side, this region will be positive, and the middle region will be negative, and the far right-hand side will be positive. All right, so these are steps that you should be familiar with, and we'll notice that we'll have a max at x equals to 3 and a minimum at x equals to 1. All right, so now that we know there's a max at -3, you should go ahead and find the actual point on the graph. So you plug in -3 back into the original. Anytime you want to find a point, you want to plug the x values back into the original. And when you do that, you should get a value of 32 for the y value. And this is considered to be a maximum point. And then I would also now take the 1 here, plug that back into the original function. And when I plug in 1 back into the original function, I get a y value of 0. And this right here is a minimum. Okay. All right, so after that, you would now go ahead and find your second derivative. And for your second derivative, I will do another line here, just underneath like that. And the numbers that you get for your second derivative, the only number that works is actually -1. And then you want to find numbers on the left-hand side and the right-hand side of -1, and you would plug that into your second derivative expression. And if you do that correctly, the region on the left-hand side will be negative, and the region on the right-hand side will be positive. And since you go from concave down, so this region is concave down, and this region is concave up, that means you have an inflection point at x equals to -1 because you're changing concavity. All right, so after that, you would plug in -1 back into your original function. And if you do that, the corresponding y value will be 16, and this is your inflection point. Okay, so let me just erase this, and I'll erase that. All right, so let me just kind of zoom out here now. So the purpose of this video is if I give you all this information here, the y-intercept, the max and min points, the inflection point, the intervals where you're increasing and decreasing, and the intervals where you're concave up and concave down. Can you use all of this, all of that information here, and can you sketch a graph? That's the focus of this video. All right, so let's go ahead and start sketching the problem here. So here's an x and y axes. Now I would go ahead and plot the y-intercept first. Now the y-intercept is around here. And then I would go ahead and plot your max and your min points next. So you need to approximate those to the best of your ability. So maybe -3 is right here and 32 is over here. And since it's a max, you can go ahead and put a max at that point because that's what it's going to look like on the graph. And then you also have a minimum at 1, 0. So 1, 0 is somewhere here. And since you have a minimum, then I would just draw a minimum just like that. So this is at the point x equals to 1. All right, after that, let's go ahead and plot the inflection point. The inflection point is at -1, 16. So here's roughly -1, and 16 is about there. Okay, And if you connect all the dots, I think the graph is probably gonna look like this. Something like that. And then we'll curve back up and then we'll finish it off. So that's a basic sketch of the graph. Okay, so that's what you should be able to do based on plotting the points. And what we're going to do next is we're just going to check the intervals by drawing a number line at the very bottom here. So this is my first derivative. So I'm just going to copy this purple result down here. And here is the point -3. Here is the point 1. And we go from positive here to negative in that region and positive over here. Okay, and I think the results do match up because this part right here means you have a positive slope, and in this region right here we do have a positive slope, and in the middle region we have a negative slope, and we do have a negative slope there. And finally, at the far right hand side, this purple region is positive, meaning you have a positive slope, so that definitely matches well. Alright, so the first derivative matches up quite well with my sketch. And then finally, I just want to test the results for my second derivative. And then I officially finished the problem there. Just erase all that. Okay, so next thing we'll do is we'll take our second derivative results and we'll plot that underneath my graph here. Here's my second derivative, and the only point I have is -1, which is this point right here, -1. And I'm concave down on the left-hand side, and I'm concave up on the right-hand side. Okay, so just remember, concave down means this, that's concave down, and concave up means that. Okay, so this whole region right here, we're concave down all the way up to -1, and as you can see, this blue region right here, that is indeed concave down. It captures that part of the concave down right there, and this yellow part right here means we're concave up, so all this is concave up, and that matches the concave up graph as well. So based on the results and my sketch, everything looks to line up correctly, and I can feel pretty confident that this is the right sketch for that particular problem. Okay, so once again, the focus of this video was to not go over all the algebra steps. I think we've done enough practice of that in class, but instead the focus is to use the results and produce a general sketch of the graph. And then at the very end, we can check our work as well. Okay, let's move on to the next graph here. We have another polynomial here. Okay, so step number 1, I would go ahead and find the y-intercept, and that happens when x equals to 0. So those would go to 0, and then 1 would survive, so my y-intercept is 0, 1. And after that, I would find the critical points, and just to kind of speed up the process here, my critical points, they happen at x equals to 0 and plus or minus √3. So you can find your critical points simply by taking the derivative and making the derivative equal to 0, and then you will get the answers of 0 and plus or minus √3. After that, I will give you a number line, and on that number line you want to put the critical numbers on there. So this would be negative √3, this would be 0, this would be positive √3, and then you're finding numbers in those regions and plugging them into your first derivative. If you do that correctly, the far left hand side is positive, then we go to a negative region, and then back to positive, meaning we're increasing with a positive slope, and then back to a negative region, which means we're decreasing, and that means we have a negative slope there. Alright, so this means we have a max here at x equals to negative √3, I have a min at x equals to 0, and I have a max at x equals to √3. After that, I would take these x values and I would plug them back into the original function, and I want to find the actual points. So once again, whenever you want to find a point on the original graph, you need to plug the x values back into the original function. Okay, and if I do that correctly here, I would get negative √3, and negative √3, the corresponding y value will be 10. So this right here is a max. Right, so you do need to work out the numbers on that. After that, I'll take 0, and if I plug 0 back into the original function, it's actually the same point as my y-intercept. But I guess what we're trying to say here is my y-intercept is actually going to be a minimum. Okay, and then after that, we're going to take our positive root 3 and plug that back in the original. And if I do that, I get positive root 3, and the y value will be positive 10, and this will be a max. Okay. After we find those points there, the next step that you would do is you would go ahead and draw a number line for your second derivative. So you would take your second derivative. So that happens by taking the first derivative and taking its derivative gain, and then you would set that equal to 0. And if you do that correctly, the x values you would get are -1 and +1. And then you find numbers in those regions and you plug those numbers back into the second derivative. And if you do that correctly, you should get concave down in that region. Then you'll get a concave up in between -1 and +1, and then concave down after 1. So what that means is you have an inflection point at -1 and an inflection point at +1. And that's because you're changing concavity. Okay, so after you do that, I would now go ahead and take these points, plug them back into your original function. And if I do that, I get the point -1 for x, and my corresponding y value is going to be, let me see, I think that's going to be 6. Yeah, -1 comma 6. So this is an inflection point. And let me erase that. And then if I take this value 1 and plug that back into there, I would get 1 comma 6, and that is another inflection point. Okay. All right, so once again, the focus of this video is if you're given all this information here, can you use those results and sketch the graph? Okay, so let's go ahead and try to do that. So in order to sketch a graph here, I will draw the XY axes right there. And I will go ahead and graph the Y-intercept first. The Y-intercept is 0, 1. So here's 0, 1. And once again, at 0, 1, we do have a minimum there, right? So since we have a minimum at 0, 1, we should draw a minimum type of graph right there. That's what a minimum looks like. And then after that, let's go ahead and plot the max points. So the max points are at -√3, 10. So maybe somewhere right here. So that's a max right there. This is a -√3. And then maybe over here, this is going to be +√3. And then I have a max there as well. So something like that. Okay. And then at the points -1, 6 and +1, 6, I have an inflection point. So 1 is about here, -1 is about there, and so an inflection point there. And here's +1 there, and that means there's an inflection point roughly there. Okay, so those are the points, and once you have plotted those points, I would go ahead and do your best to connect all the dots and sketch the graph. Okay, so if I just follow the graph using a bit of common sense here, I think this part of the graph will level off like that. This part of the graph should level off like that. And I guess this graph will slowly kind of connect like that and like that. Okay, so this right here is the point √3, 10. That's a max. Over here, this point is -√3, 10. That's my min. And I also have that's a max. Sorry, that's a max. And I guess I have a minimum point here at my Y-intercept, which is at 0, 1. Okay, so that's what my graph kind of looks like, and what we're going to do next is I'm going to use my first derivative test right here, and I'm going to just put that underneath my graph, and I just want to confirm that the results do work. Okay, so this is going to be -√3, this is going to be 0, this is going to be +√3, and the results go like this, positive, negative, positive, and negative. And let's just see if the results work here. This region means I have a positive slope. And as you can see, this region right here is indeed positive. There's a positive slope there. And in this region right here, I have a negative slope. And that means there's a negative slope right there. And then there's a positive slope in that green region. And that region right there is positive slope as well. And then finally, at the very end, there's a negative slope. And this region right here, it has a negative slope. All right, so my first derivative test, the results all work. So I'm just going to erase all this now. And then I'm going to now check my second derivative. Let me just carefully erase all this. Whoops. Okay, and then after that, let me just kind of get back to my original screen here, erase that. Okay, and then let's go ahead and use my second derivative results right there. Okay, let's draw another line underneath my sketch here, and the numbers I need are -1 and +1, and this whole region is concave down. This region is concave up, and this region is concave down. Now remember, concave down looks like that, concave up looks like that, and concave down looks like that. Okay, so in this region we're concave down. All right, so this region right here, that refers to this whole region right here. And that represents this part of the graph on the concave down graph, so that looks correct. And then finally over here we're concave up in that purple region, so from -1 to +1 right there, that region is concave up, which looks like that. And finally at the very end, this part is concave down, so this whole region right here, this green part is concave down, and that represents this part of the graph as being concave down. So I feel pretty confident that those results actually work. Okay, so that concludes that particular video, and then now we're going to move on to the very last one. Okay, so once again, we're going to skip all the algebra steps, and we're just going to get to the key parts for the. Sorry, we're just going to give you the key features again, and then we're going to use those results to graph this function here. So step 1, let's find the y-intercept. And that happens when x equals to 0. So that's 0, that's 0. So 0 times anything is going to be 0. So my y-intercept is at 0, 0. And then my critical points happen when x equals to -2 and -1/2. All right, so make sure you can do that on your own. And then I would draw a number line here, and on that number line, I will plot the points, the x values of -2 and -1/2. And the results would be negative in this region, negative in that region, and then we're going to be positive in this region. Okay, so that means we have a minimum when x equals to -1/2. All right, so the next step is I would take this value of -1/2 and I would plug that back into the original. And if I do that, I would get -1/2 here for my x value, and my corresponding y value would be -27/16. And this would be a minimum right there. Okay, now this critical point of -2, since we don't change signs, we don't have a max or a min, so we can expect the graph to maybe level off, something like that, with maybe a small horizontal tangent line there, but there is no max or min when x equals to -2. After that, I would now take your second derivative. And when you take your second derivative, the x value that makes the second derivative equal to 0, there's actually two of them. There's going to be -2 and -1. And if I plug in the numbers correctly, this region will be concave up, this will be concave down, and this region will be concave up. And since I changed concavity, there's an inflection point at x equals to -2 and an inflection point at x equals to -1. And once again, you want to take these values, plug them back into your original, and if you do that, I should get -2, 0. All right, so this is going to be an inflection point, and then I'm going to take -1, plug that in over here, back into the original. So when x equals to -1, the corresponding y value will be -1, and this is also an inflection point. Okay, so once again, the name of the game is, if I give you all these results, can you use these results and sketch the function? Now that I have gathered all the information, the plan is to now sketch the graph. So let's go ahead and sketch the graph by drawing a x and y axes right here. Step number 1 is I would graph the y-intercept, which is at the point 0, 0. After that, I would graph this minimum point, which is -1/2 and -27/16. So maybe -1/2 is right here, and -27/16 could be down there. And then I have an inflection point at -2, 0. So -2, 0 maybe is over there. And finally, there's also an inflection point at the point -1, -1. So maybe around there. Okay, and since there's a minimum, sorry, I should go ahead and also put a minimum kind of a graph right there, and after that we should do our best to connect the points here. Now the right hand side is a bit easier to figure out. It seems like that's probably gonna connect like that and just shoot right up, and then it just seems like on the left hand side we do have to do our best to connect the dots. So I think the dots will look like something like that, and then over here at 2, 0, it's an inflection point, so it's probably gonna level off like that, and then it's probably gonna just shoot up like that. Okay, so there is my general sketch right there. My inflection point, if I redraw that in, this is the point -1, -1. This is the point -1/2, -27/16. And this point right here was the Y-intercept, which is 0, 0. Okay, so there's my sketch right there. And after that, what I'll do next is I will draw the first derivative again, just underneath this graph. And I just want to verify my results. So this is going to be -2, this is going to be -1/2, and it looks like this region here is going to be negative, and that region will be negative, and this region will be strictly positive. Okay, so if this part right here, since it's positive, that means I need to have a positive slope, and as you can see, this part of the graph, I do have a positive slope in that region. So that works with my first derivative test. In the middle region, the slope has to be negative, and this looks like to be a negative slope. So that works out great. And finally, in this region right here, this purple region right here has to be a negative slope, and this right here does indeed look like a negative slope. So the graph looks pretty good based on my first derivative test. Okay, after that, just to finish off this problem, I will go ahead and graph the second derivative. Sorry, just match up the second derivative results. So let me just draw another number line here. I need the points -2 and -1, and this is going to be concave up. This is going to be concave down, and this whole region here should be concave up. Okay, so remember, concave up means the graph should have some properties like that. Concave down resembles that graph of a parabola opening down, and concave up is a parabola opening up. Okay, so let's go ahead and take a look at this. I think the easiest part to check is probably this blue region right here, concave up. So that represents this entire blue region right there. And that blue region represents this part of the concave up graph, so that matches, which is great. And then I have this green region right here, which represents concave down, and that represents this part of the concave graph right there. So just make sure you're aware of that. So that matches up with that. That looks pretty good. And then finally over here, this is concave up. So this part right here is concave up because it matches this part of the concave up graph. So I should feel very confident that that sketch does match up with my first derivative and the results for my second derivative. Alright, so that concludes this homework video guide. Just make sure that you are good with the algebra steps, because once again, the purpose of this video was to skip all the algebra steps and just work from the results.